a very high-level overview of JavaScript so that you guys can get a feel of where we are heading towards and so on. So one of the best resources out there to learn JavaScript is from the Mozilla Developer Network. So if you go to the MDN site, or you can probably Google MDN and say Real Introduction to JavaScript. The first search result which you see is developer.mozilla.com. This is one of the most simplified and the comprehensive JavaScript tutorial out there on the internet. There are many out there, but I prefer this one because it starts and it ends with everything. So I'll probably walk you through the same thing so that once the session is over, you guys can go through more concepts of JavaScript from here directly. This has a section where how JavaScript has started, how Brendan Eich invented the JavaScript or created the JavaScript in 10 days, how the language has started as ECMAScript, how language was started as JavaScript, and why it was named as JavaScript. I'll walk through the introduction part pretty quickly so that you guys can read through the history. Brendan Eich, who was an engineer at Netscape, was the guy who actually invented the JavaScript. At that particular time during 95, 96, if you guys didn't already know that, Tim Berners-Lee is the father of internet. So he created the HTTP protocol. So if you guys didn't know that, the world's first website is created by a company called as CERN. So for all of us out there, if you have never seen the world's first website, take a look at this. So simple, right? No animations, no funny ads, nothing, just pure markups and document. This was the initial purpose of the web. The World Wide Web was initially used as a hypermedia or transmitting information between two endpoints. So the people at CERN wanted a system where they wanted information to be transmitted between a network. So the people at CERN want to exchange data between each other without keeping bunches of files. So they wanted a medium in which you can transmit data from one system to another as hyperlinks. That was the initial purpose of the web. Later on, people started using it more and more, and they wanted to make it dynamic. So Internet Explorer came up with the VBScript. The Java people came up with the applets to make the web dynamic. Netscape people wanted to get in the competition, and they wanted to release another dynamic language that can be used to control the web. So they came up with JavaScript. Brendan Eich created this language in about 10 days, taking features from multiple other languages and then building it up. The reason he had to do, the biggest challenge which Brendan Eich faced during creation of JavaScript was that none of the operations on the web page should be synchronous. The idea behind that is that when you click a button and you have an operation in the background, your screen should not freeze till the operation in the background is completed, because that would create a poor user experience. So Brendan Eich had this biggest challenge that everything in the web which you see, when you click on a button, it needs to be released immediately, but the process should happen in the background or asynchronously, if you didn't already get that part. So you must have worked with asynchronous calls and other things in your daily work life. So nothing special about it, but this was the reason behind why it is being asynchronous. So the main thread which controls the UI thread, the user interface part of it, is always free from the processing. We are going to look at that more and how that one feature made JavaScript very special today. Moving ahead, you can read about how it became ECMAScript, how it was moved to ECMAScript 3, and how ECMAScript 5 was published in December 2009, and ECMAScript 6, which is a very big change that is going to happen in another 6 months, it was supposed to be published in 2015. So in the entire session, what we're going to talk about, we're going to talk about ECMAScript 5, and I'll try my best to give pointers where ECMAScript 6 is going to come into picture while working with JavaScript. Moving ahead, we'll start off with JavaScript from a language perspective. I, for one guy, believe that doing is better than actually, reading through stuff. So this is something which I do for myself when I'm working with JavaScript or any other language. I try to open the console or any kind of a compiler and then write code and test it out on the fly. So that helps me understand the concept very easily. At the same time, I can do I'll understand the syntax as well as the concept pretty easily. So that's what I do. So when you guys are also working with JavaScript, in case you're doing any browser-related activities, I would recommend using Firefox Developer Edition or the Google Chrome browser to work with it. Because both of these browsers have a very good developer console. All you can do is that open a new tab, nothing inside it, just open the developer tools and click on console. Let me clean up my console and then bring it up. Sorry for those errors. Here you can start typing your JavaScript code and test it. Say var a equal to 10 and var b equal to 20. Say c equal to, var c equal to a plus b. Then you say you can directly print, c like this, or you can check out some other properties. As we go along, I'll show you a few debugging tools and places where you can find to help you test your JavaScript code pretty fast. Since you guys are mostly basic developers, I highly recommend doing things. So what we are going to cover are basically concepts of JavaScript, which are going to be theory, but I highly recommend putting them into action by opening a developer console. For the next 15 to 20 minutes, I'm going to run you through the basic stuff of JavaScript. Later on, once the session is over, we are going once we introduce you to Node.js, and I'm going to talk about objects in particular. Okay. So in JavaScript, we have basically a number, string, boolean, function, and object. The first thing when you guys come from another programming language, you need to understand is that this is a scripting language. First point. Second point, if you are coming from a Java background, I see most of you are, that's an object-oriented language, whereas JavaScript is object-based language. It runs purely on prototypal inheritance. You can read more about that, or we're going to talk more about that as we go along, depending on the scenarios arise. Scripting, the beauty of scripting is that you really need not decide anything when you're writing it. Let the compiler figure it out. Okay? So you say it's a number. In JavaScript, as I mentioned earlier, we're going to talk about ECMAScript 5 alone. So I'm going to talk about ECMAScript 5. So to create a variable, you say var a equal to 10. Now a is of the type number. You can simply check type of a is a number. Simple thing. So the easiest way to understand JavaScript, as I mentioned, is to just open a console and start typing it. Next, the other types of JavaScript are string, boolean, function, and object. Everything is instantiated using the var keyword, or declared using the var keyword. Whatever value gets assigned, the compiler is smart enough to figure out the type of it. So this makes a lot of things easier or difficult based on how you are coming from. For me, when I came from Java to JavaScript, it was pretty much tripping that the fact that I am not able to declare the type of a variable. Soon, I understood the fact that I need not worry about those things up to a certain level about what kind of variable it is rather than get the job done. So I might be using the word get the job done a lot because that's how JavaScript is. It's scripting and it is very fast and easy to use. There are two more types which you can actually use. One is undefined and null, right? So undefined, to be honest, I have very little used null in my whole JavaScript experience in 1.5 to 2 years. But undefined is something which you use pretty frequently, and you'll see a lot of third-party libraries use it. Another type of JavaScript type is an array. Okay, this is arrays, functions, and objects are all objects in JavaScript. To be honest, anything in JavaScript is an object. So we're going to deal about that in a bit different way as we go along. The different types as we see are number, string, boolean, symbol, that is ECMAScript 6 feature, and an object. An object consists of a function, array, primarily, and then a date rejects all these come under objects. Your null and undefined are the other types in JavaScript. You can read more about what each type is, what they do, and so on from this particular page. The declaration, as we have already seen, is using the var keyword. Var a, var name equal to something, and so on. If you do not add a var, the variable is hosted in that particular scope. We're going to talk about this a bit more when we look at the global variables in JavaScript. what happens is when you declare var a equal to 10, this value is available only in the scope of that particular function. Whereas one quirk in JavaScript is that if you say a equal to 10, it gets added to the global namespace. So this is a common issue in JavaScript that all variables move to the global namespace directly if you do not use a var keyword. So there are other ways to check or protect against it. We'll talk about that a bit later. The next part is operators in JavaScript, the same way how we do in any other programming language. But one big catch in JavaScript is that, so if you say 3 plus 4 plus 5, it becomes 345. If you say 3, 4, and 5, it becomes 75. The point here is that if you take a string and add it with an integer, it automatically becomes a string. Adding an empty string to something is useful when you're converting it directly. But if you do a concatenation with that, it automatically gets converted to a string type. That is one big quirk. So you have to be very, very careful in JavaScript when you have var a equal to 10, var b equal to 20, and then you say c equal to a plus b. The value of c being 1020 and not 30. So this is an implicit conversion which JavaScript does, adding up these two values, making it a string. I'll tell about why without adding the var it goes to the global namespace a bit sooner when we are dealing with more complex functions. Since we are at the very basic stage, we're going to do that. Right? Okay. Cool. So for this very reason, right, you have to be very careful with JavaScript. Primarily, there are two types of ways of checking a value in JavaScript. Let's say that we have var a equal to 10 and var b equal to 10. If I say a double equal to b, it's going to return true. When I say a triple equal to b, it's going to return false. This is another quirk in JavaScript that if you use a double equal to operator, it checks the value. Whereas when you use a triple equal to operator, it checks the value as well as the type. So you have to be very careful when you're checking values. The recommended method of doing things is using a triple equal to check the values, because you're always checking the value as well as type. Unless until it is explicitly intentional where you just want to check the value irrespective of the type, you can use the double equal to syntax. So as you can see here, also JavaScript does another thing called as a truthy and a falsy. This is something which is pretty much different from other programming languages, which caught me off guard when I started working with JavaScript. One is considered to be true. An array is considered to be true. An object literal is considered to be a true. The word true is considered to be a true. An empty string is considered to be untrue, right? So if I say something like this, oops. Okay, I'm sorry, I just did something wrong. Okay, so it is considered to be a true if you have a string literal like this. Okay, whereas when you have undefined, this is considered to be a false. Null is considered to be a false. 0 is considered to be a false. A false is considered to be a false. So there are things which are truthy and which are falsy. So you might be seeing expressions in JavaScript where people write var arr. It's supposed to be an array, and then say if arr. They do not check if arr.length is greater than 0 or so on. So that's one thing which people do in JavaScript, which we look at it when we work with the language more. Next thing is the if-else constructs, which you guys can see. The same thing as in any programming language. The while loop, the do-while loop. And then the double and double or operators in JavaScript. This is the same as the short circuit language in any short circuit logic in any other language. This particular logic is used while assigning default values to variables. For instance, you have a name. If you want a value which is being passed from the function to be assigned to a name, you set the default value from the function. Otherwise, you want to set it to a default, you use a double OR operator. For instance, you can do this where a equal to, let me add a function called as add. Sorry. I would say where c equal to a or 5, where d equal to b or 10. This is the definition of my add function. I'm sorry for the console logs. And we say return c plus d. Now if I call the add function without any arguments, I get 15. Because this is undefined, this is undefined. This becomes false and this value gets assigned to this. This is one way of setting default values in JavaScript. That's how a lot of libraries do it. So if you're passing some variables to a function and you want to make sure that some default value is assigned, if there is no value provided here, you use a syntax like this. This is like double OR operator for short circuiting. If this value is evaluated as false, this value is being assigned to C, and if this value is evaluated as false, and this value will be assigned to D. As you can see from here. Also the conditional ternary operator, which is pretty much similar in most of the languages. You say if age is greater than 18, yes, otherwise no. Switch case is common to any programming language. We're going to talk a bit more about objects later on, but this is just a high-level overview of objects. As you can see, JavaScript objects can be thought of as simple collection of name-value pairs, dictionaries in Python, hashes in Perl or Ruby, hash table in C, C++, hash maps in Java, associative arrays in PHP. The way you create an object is using the var syntax, var object equal to new object. Or you can also use this literal notation to generate the object. In JavaScript, we do not have classes. That is something which is quite different from the other object-oriented languages. As I mentioned earlier, this is an object-based language. So here, you have a function with a capital P. In JavaScript, the convention is that if you have a capital letter for a function, it is treated to be a constructor. The language does not make sense of whether it being a capital letter or a small letter, but it is more of a developer convention that if any function starts with a capital letter, it is a constructor. The behavior is pretty same. We initialize it with, we create an object from the class using a new keyword, something like this. We are creating a new person named you, right? You can also do the same thing, the person, by using this syntax, object.name equal to Simon. Once created, an object's property can again be assigned in one of two ways, that is this property. One is object.name, that is you.name is Simon, or var name equal to object.name. And another way to do that is using the bracket notation. The next part we're going to deal about is arrays. When you create a new array, you use the same syntax using the new array and a of 0, a of 1. A more convenient notation or rather a JavaScript way of doing things is using the bracket notation. This is what you'll find more in most of the common programs written by developers than this syntax. There are a few array methods which help you do things pretty easily. Most of them are common in other languages like push, pop, join, sort, splice, and shift and unshift. Next part of the concepts is functions. Basically, a function, as we have seen earlier, takes in arguments and returns a value. The only thing which is different from a normal function in other languages and a function in JavaScript is this particular property called as arguments. In JavaScript, you can pass in any number of arguments to the function, and this variable, which is scoped inside the block of the function, consists of all the arguments. So for instance, you have an add method which consists of n number of arguments, and you want to pass any of them and sum them up. So you do not have a finite number like 2 or 3 or 4. The beauty of JavaScript is that you can pass in any number of arguments like this, and using the argument syntax, which is an array, you can actually iterate through it and then sum it up. This is one thing which is quite different from other languages. Similarly, the average function using the arguments. You guys can read through more about these things. We're going to talk about custom properties and custom objects a bit later on. Okay, great. So let's go back to the concepts of Node.js rather now. By the end of this particular session, we'll be targeting to work on the following concepts. Understanding object-oriented programming in JavaScript, which we started in attempt. We'll continue a bit later. We'll understand what Node.js is and how it works. We'll work with the command line interface and REPL for Node.js. We're going to install Node.js and NPM on your machines. We're going to work with NPM, that is Node Package Manager, and we'll probably spend some time coding your first Node.js program today. So to keep things a bit light, I'll introduce you to the Node.js at a high level. As we go along, we're going to talk about the real-time use cases, hands-on examples, and so on. So what is Node.js? Node.js is an open source cross-platform runtime environment for networking applications. If you did not already know, Ryan Dahl was the guy who actually created or invented Node.js. The way it started off was that he was using this photo sharing application called as Flickr, and he started uploading a picture to the server. He noticed that till the picture upload is completed, the server was not able to respond to any other thing associated with that particular client. Ideally, what happened was there was a server running in the background which was uploading a picture, and he was trying to navigate to a different page clicking on the link. Since the main thread of the application is occupied by the I/O operation of getting the file from the client to the server, the other parts of the application got blocked. So Ryan Dahl wanted to find a way where he can upload or do multiple processing at the same time without the main thread being blocked. So if you guys understand what I mean, he should be able to do all the non-blocking operations simultaneously. The biggest concern what he faced was, or upon analysis he found out that any input-output operations that deals with saving a file, opening a file, talking to the database, talking to another server over a network request, all this block the main thread. So typically how other languages also do is the same thing. So what he wanted was he wanted to implement a mechanism or a server or some kind of a technology piece that can do parallel processing without utilizing more number of threads. So he started implementing this very concept using different languages like Java, .NET, VB C#, and so on. But no other language was able to achieve what he was trying to do about the non-blocking way of doing things. Then he came to JavaScript. During 2007-2008, that was the time Google released its famous JavaScript engine, Chrome's V8 engine. This Google Chrome V8 engine is the JavaScript engine released by Google, which is considered to be the fastest JavaScript engine as of today. It has the ability of processing JavaScript quite fast with its pseudo classes concept. We are not going to cover much about the V8 engine, but we are going to look at how it works. So Ryan Dahl took a dig at implementing this particular feature, what he was talking about, using the Chrome's V8 engine. It worked out pretty fine, and then he wanted to implement this at a very large scale. Then a company named Join started taking this project as an open source, and then they funded Ryan Dahl, and he worked with Join for a few days to develop it what it is today. So that is a quick brief history about Node.js. Coming back to our slide, as you can see, it's an open source cross-platform runtime for networking applications, and then which is primarily for non-blocking purposes. It is built on top of Google Chrome's JavaScript runtime, or the V8 engine. This lets us build fast, highly scalable network applications just using JavaScript. Now that people are familiar with JavaScript on the client side, if you are aware of JavaScript, in general, you can work with an end-to-end application with the power of Node.js. This whole framework, or this whole server, rather server is a very cornered word for Node.js, it's basically this whole runtime is asynchronously driven. And then the primary condition, as with any JavaScript language, it is single-threaded. So you not worry about deadlocks and multi-threading. Almost no function in Node directly performs I/O operation. So the process is never blocked. Because nothing blocks, less than expert programmers are able to develop scalable application. This is a statement given by Node.js itself. Node.js is event-driven and it uses an event emitter model to perform things. So we're going to talk a bit about the way Node.js does things. So we're going to talk about something called as an event loop. An event loop is the mechanism or the technology which enables Node.js to do things this way. Just because Node.js is single-threaded, that doesn't mean that you cannot have multiple codes in your application. You can do. There are ways you can implement a Node.js application which can use multiple codes in your application. And the best part is that you do not stitch anything together. There are processes or models available there. Yes, we're going to talk about how Node.js is single-threaded and do parallel stuff a bit later. So we can fork or spawn child processes from the main process and then work with it. So this lets us spawn child, this lets us even fire shell commands or even start applications right from your Node.js app. We're going to look at that part also a bit later when we're going to build command line applications using Node.js. The concept we are familiar with that is if one egg takes 15 minutes to boil, 10 eggs will take 15 minutes or 20 minutes practically and not 150 minutes. Porting the same logic to a web application, we know that if one particular user requests a page and if it takes 1 second, if 100 users connect, it should take probably 3 seconds or 5 seconds but not 100 seconds. So using this concept in mind, so what they have done is, that we made the main thread asynchronous. So using this concept, like if one user requests a page and it comes back in 1 second, if the second user requests the page simultaneously as the first user, it still should come back in 1 second. It does not make sense for it to take 2 seconds to return back 2 pages. So Nginx server uses this particular principle. As you see from this graph, if the requests keep increasing, the speed at which it processes decreases or the concurrent connections decreases. Whereas the orange line which you see here is Nginx, which basically can serve more number of requests or concurrent requests at the same time, whereas an Apache server cannot because it uses one thread per request. So what Node.js has done is that it has implemented something called as an event. Implemented something called as an event loop. Using this event loop, it kind of processes everything. So let us assume that a user has connected to the server and started making a request. When the user starts making a request, it goes to the main thread and the operation it needs to be performed is sent to an event loop, which runs in a separate thread pool and then executes that particular operation. Once that particular operation is completed, it is then again queued back to the event queue. Okay. Taking our scenario, let us assume that we have a web application. The web application sends a request to the web application, basically gets a request to an endpoint. It goes to the database, gets some data, and sends the data back to the client as JSON. If this whole operation needs to be performed by a typical server, what we do is that we make a request to the server. The server then contacts the database, gets the response back on the same thread, and then waits for the response from the database on the same thread, and then sends back the response on the same thread. This is how a typical server would work. But whereas in case of an Apache Nginx server, what happens is that once the server gets the request, it takes it and assigns it to an event loop or an event queue, saying that, okay, this particular request needs an I/O operation which needs to go to the database and come back. Once it goes to the database and comes back, I need to send the request back. So the event queue takes a request of making an I/O call to the database. It goes to the thread pool, performs this operation, and once this operation is done, till the operation is completed, the event loop or the event queue is free to do other things. So this is what makes the Nginx server very powerful. The problem is that the point is that once the first operation of the database is completed, it again queues back to the event loop. If any other request is being processed, that will get executed, and then this new request will be sent to the event queue to be executed. So let us assume a scenario where there are two users who are coming in. User 1 going through the same path of making a DB call, user 2 going through the same path of making a DB call. First, when the user 1 comes, his request queues up, it identifies to be an IO operation, it gets pushed to the event loop, and then it makes the IO operation, and then the main thread is free. Second request comes in, the same thing happens, the main thread gets free, everything gets queued to the event queue, and then an IO operation is done. Once the DB request is completed, that particular thread will report back to the main thread saying that, okay, my operation is completed, execute the callback of this. So once the operation is completed, the main thread will execute the core functionality of the application and send back the response to the client. So this is how the concept of non-blocking or asynchronous works. So Vineet asked this question like how event queues identifies the users. So JavaScript has a concept called as closures, which we'll discuss a bit later, where the properties as well as the information needed to process the request is encapsulated and sent to the event queue. So when the operation of DB is completed, it executes the values based on what it is stored. We'll talk more about event queues. So Kapil asked this question saying that so all events will be only in sequence, no more shared memory issues. All the events will be in sequence, but I need to cross-check on the memory issues because JavaScript uses something called as closures to maintain all these objects and values to be persisted in the event loop when the operation executes. So I just need to cross-check on the memory part. Okay, good. So this is just definitely better user experience if you ask me. I mean, using a nominal server or a small scalable server, you can implement your a scalable application. So that is one way to put it. If you're looking for the word user experience, yes. Okay, in JavaScript, so let us take a quick example of how things work. Let us say that we are trying to use a function called as read file, which goes to some location on your hard disk and reads the files. The typical way of doing it in any language, consider this to be a pseudocode, is that we say a read file and then you give the path to the file and then you console log contents. And then you have another operation which runs parallel and which has nothing to do with the contents. The Node way of doing things is that this is a blocking code. This another independent operation does not have anything to do with this. So why should this operation be waiting because of this particular process? So that is how this particular piece of code is a blocking code. Whereas when it comes to JavaScript and how you write non-blocking code, you say a read file. You pass the file to the method called as read file, and to the second argument you pass a function. The function is called as a callback. This is the function which gets executed once the read file operation is completed. So typically what we saw earlier, the event loop being executed, so whatever is getting pushed back to the event loop after the operation is completed will be executed inside this function. This is how it works. The read file method gets executed, reads a text file. Then it goes to the event loop operation completes and it pushes this particular response to the event queue back. And then the event queue will invoke this particular method and then send the values to this method so that you can start processing the contents. Now you see the console log. This particular another independent operation will execute asynchronous. Like it is once line number 1, if you say this one where contents equal to read file gets executed, it does not wait for the second line to be completed or the callback to be completed for the next one to be executed. In the first scenario, line 1 gets executed, it waits for the response of line 1 to come back, and then line 2 is executed, and once this is completed, then line 3 is executed. So this is how the top piece of code works. In the bottom piece of code, line 1 gets invoked, the callback gets registered for the read file method, over. Line 2 comes in, gets executed. So this is how a non-blocking code works. So pretty much this is how Node.js does things asynchronously using the concept of event loop and the callback feature. This is the main reason why JavaScript was used or picked to implement this feature. As of today, Node.js supports both Windows, Linux as well as Macintosh pretty well. Natively it was inspired for Linux-based systems, but the support is pretty good even today also. There are some quirks with Windows regarding the number of folders, number of folders that it can nestedly create and so on. These are some things which might be a cause of concern when working with Node.js, primarily working with NPM modules. So while deleting a project or removing it and so on. So if I'm not wrong, in Windows you can delete only projects which are 40 levels nested deep. If you have deeper nesting, you might run into other issues also. So yeah. So we'll look into that also a bit later for Windows. So just a quick poll check. How many of you would like to do stuff hands-on as we go along? I cannot promise everything, but we'll try to do small things on your machines to set up. So quick check if anybody would like to do that. Okay. 2 yes, 3 yes, 4. Looks like everybody would like to do it. Great. So then in that case, right, I am using a Macintosh, Apple MacBook Pro to do this. If you guys are Windows users, you might run into some issues while working with command line interface of Node.js. So the native command prompt of Windows is a bit tricky and sometimes might land you into issues. For that, I recommend you guys downloading the Git SCM. So you can go to git-scm.com. Yes, Linux is same as the Mac, but there are the support for Linux is not same as the Mac. They are different distributions. You might run into different issues with Linux when compared to a Mac. So that was a question by Vasudev whether Linux should be same as Mac. So there's a small difference. So most of the packages do support, but there are issues. Okay, coming back to our Windows people. So if you are using Windows, I highly recommend using the command prompt which you get from Git SCM. So if you did not already know, Git is a concurrent versioning system, something similar to Subversion, but it is a bit different on how it saves files. So if you're not familiar, you can go through the documentation. The only thing you're looking forward from the Git SCM download is the Git bash. So most probably Windows guys might run into issues, so I highly recommend using the so we are using the so while working with Windows command prompt, it might get a bit tricky while running Node commands. So that is why we are using Git SCM on Windows to manage all these things. Git SCM provides a Git bash, which is basically a shell to work with Windows commands using the Linux syntax in a very simple term, but it is way sophisticated than that. So, that's why we use Git SCM to manage all our command line. And if you did not already know, Node.js runs mostly on command line. Everybody, we can all go to the site called as NodeJS.org. This is the official site for Node.js. You must have already landed here a few times by now. So here you can see the information about Node.js, its documentation and so on. I'll quickly walk you through setting up Node.js from here. One option is that you can click on the install button here. So if you see on the bottom left hand corner of my screen, you can see it's a node-0.12.2.pkg file. If you're a Windows user, you might get an exe version of it and so on. So if you would like to download a specific version of Node.js, you can click on the download links on the top of the page, and then you will be landing into a section where you will find all the installers for your application. If yours is a 32-bit installer, you can pick that, 64-bit, and so on. If you would like the source code, you can download the tarzip file and then build it locally also. Building from a source file is not part of the training, so we would directly be downloading the installer and start working with it. So for me, I'm using the Mac, so I'll click on the download link for the Mac OS X.pkg file, and this is going to download an installer for me. I'm going to put it up in some place where I remember. And then once the installation is completed, you can click on the link and you'll be able to see the same installation process with any software. Node.js installation is one of the most easiest installations I've seen so far, because once you have Node.js installed in your machine, the possibilities are literally unlimited. We'll explore that as we go along. So you can click on continue. There are no specific settings. All you need to do is agree and then install. So as far as my system goes, I already have Node.js installed, so I'm going to cancel the installation process. Great. So for all the people who have installed Node.js, right? So since you don't have git SCM installed on your Windows machine, all the other users or everybody can open their command prompt or the terminal in your system. Once you open the command prompt or terminal, you should be able to run node space -v. Excuse me. And it should give you the version of Node.js that you are running. This is a small check on if Node.js is working or not. If you're not able to see node -v, it gives a command like node is unrecognized or is not a command. You can just ping and then we can copy. So this is one indication that Node has successfully installed on your machine. So some Windows users, after installation of Node.js also, might get an error saying that Node is not a recognized command. So after this session, you can restart your system so that your environment variables are updated. If still the environment variables are not updated, which happens in a very rare scenario, you can open the location where node.exe is present and add it to environment variables. So this way you can access node -v on your machine. So when you're using git SCM or a git bash to run these commands, a lot of them will be very similar to how you do things in Linux. So in your machines, you can just type node and hit enter. When you just type node and hit enter, you will be entering into a node shell. This is called as node REPL, R-E-P-L. It stands for read, eval, print, loop. It's as good as your browser's console. Typically, if you open the Chrome browser and run a command inside its console, this is exactly same as how it happens in the Node.js, because they both run the same V8 engine for JavaScript processing. When you hit node, you get this terminal. This should happen both in Windows as well as Mac. Now you can type in simple JavaScript commands like var a equal to 10, var b equal to 20, var c equal to a plus b, and then you can say console.log c. This is the Node's print, read, eval, print loop, which is pretty similar to other programming languages shell. The big burning question of JavaScript, if you see this, we ran the same commands what we ran inside the browser inside the Node process, right? So the biggest difference between running Node inside a browser and running Node inside your Node shell or Node.js application is the global object. Inside a browser, the global object is a window. If you look at it logically, a window makes sense. Because you're running everything inside a window, this is the global object is a window. Whereas when you run Node inside, when you run a program inside Node.js, the global object is something called as a process. So that makes more logical sense because this runs on a process. In your read, eval, print loop, if you just type the word process and hit enter, you can see the entire information of your Node.js. The title, the version, the module load list, the way in which the bindings and other things happen, the versions of the Node modules which is installed on your machine, the architecture, the platform, and so on. All the installation locations, properties, and information regarding your application. So this variable called as process is the global variable. So if I'm not wrong, process.pid gives the process ID for the thread in which Node.js is running on your machine. This is the primary difference between JavaScript on the client versus JavaScript on the server. The global object is window, and things are event-driven from more of a HTML or a visual element perspective. Whereas when you run JavaScript on the server or inside the Node shell, it runs on a process level. Is this clear? The main difference between JavaScript on the client and JavaScript on the server. As you can see in the read eval print loop, you can write same JavaScript programs as you have done. You can even create functions and execute them here just to test it out. But to make things simple, we're going to do in a different way. So you can kill this Node terminal by pressing Control-C twice, and then you'll be out of the Node REPL. To keep this training more organized, and in case we do any trainings, any examples in the session, during the session, you can create a folder structure on your machine which is similar to mine, like this, and then you can use that to work with it. So primarily we are going to look at a couple of small examples in Node.js so that you can get a feel of how to write a Node.js program and how to execute it. You can create a folder called as code examples. Since this is the first session, I'm calling it session 1. I'm going to create a new folder inside it called as example 1. So when you look for the code on Edureka's site while browsing through it, the folder structure is going to be pretty similar to this. So since this is the first example, I'm going to create a new file inside it. So you must have assumed by now that any file we work with in JavaScript area is going to have an extension called as .js. Sorry, in Node.js, we're going to use .js extension. This particular file is a simple JavaScript file where you start writing your JavaScript code. So we'll just create a function called as add. Then we'll have two variables called as x and y, and we say return x plus y. A simple JavaScript program. And then I'm going to call the function with an argument 1, 2. I'm going to assign it to a value called as z, and then I'm going to console.log z. You can create a JS file anywhere on your machine, something like this. And the way you execute a Node application is that you would open a command or a prompt at that location. So probably I'm going to close this prompt which is pointed to my root folder, and then open another prompt at the folder where the index.js application is present, that is this. Now the way I execute this program is run node index.js, and then you should get the output. I'm going to give you 2 minutes to run this example on your machine and check it out. If anybody is facing any issues, feel free to drop me a question. So I am hoping that everybody has completed, is able to run this. So this should give a basic feel of running a JavaScript application inside the Node.js environment. This is not rocket science, and this is not the typical hello world program that we usually run. Just a program where you can see some kind of operation going on. So I had a couple of questions from the guys here, say asking about the IDE and tools and plugins and so on. Primarily, there is no official IDE like Eclipse for Java or Visual Studio for .NET for working with Node-based applications. I've been working with quite a lot of editors till date, and I found Sublime Text to be one of the perfect examples or perfect editors for working with Node.js. In this session, we are not only going to focus on Node.js, we're going to talk about both end-to-end development using JavaScript. So if I have seen that Node.js is one of the, the Sublime Text editor is one of the best editors out there for developing web technology-based applications. Sublime Text is very lightweight and easy to use. You can get that. If you would like to shell out a few bugs and want a more professional editor, you can consider using WebStorm. WebStorm is an IDE which has built-in tools for node debugging. We're going to look at node debugging if you're not using WebStorms, how to do debugging of a Node.js application here. So, sorry. Coming to Sublime Text, there are packages out there which you can install along with Sublime Text to work with it. As I mentioned earlier, Sublime Text does not install all these plugins by default. There is a site called as packagecontrol.io. Depending on the version of Node.js you have installed on your Sublime Text you have installed on your machine, you can pick up the script for Sublime Text from here. So, for example, you have downloaded Sublime Text 3, which is an open source IDE. You can copy this complete script, go back to your Sublime Text, press Ctrl+, and you get this shell for pasting the place. There are two areas, one on the top which shows the process of the execution, and one at the bottom where you can paste this command and execute it. When you execute this particular command inside your freshly installed Node.js, you get the support of package control. You can then press Ctrl+P on Windows, Command+P on a Macintosh, and then you can type install. When you type in install, you get this option of installing packages in Node.js. You guys can probably play through the video and see what I've mentioned. And then when you hit enter, you get a list of packages that are supported by the IDE. As of now, there is one package which I recommend you guys to use that is called as opening a terminal. So when I do a right click, I have an option of open terminal here. So this is a simple option that you would need when you're working with Node.js because you would be executing the code inside your terminal. When you search for a package, and then you can search for terminal here, and then you would get this package and you can install it. Once that is installed, Sublime Text might ask you to restart it. If not, you can directly right click on any file and you should see this option called as open terminal here. And when you execute that, a terminal will be opened inside that folder so that you can easily execute your Node program. This is a simple plugin we can add for now. I'll show you a few more plugins as we go along. Node.js has also debugging capabilities of the application, which we're going to take a look at. Before that, we're going to talk about something called as Node Modules. So we spoke about REPL, the read eval print loop. It's a simple command line tool to interactively run JavaScript and see the results. Just type Node on the command line and hit enter. Once you do that, you enter the world of Node.js and you can start interacting with it. We already wrote our first program. We console logged the sum, basically more than what we did. And also we created another file called as index.js, and then we pasted an add program and then we executed that. We ran it by using node filename.js. So Node uses a concept called as modules. The main thing with JavaScript, as we know of from the client side, is that all the functions or variables go and sit in the global namespace. You create a function which is encapsulated into another method which sits inside the main method. So if you are new to JavaScript or have a very basic idea of JavaScript, this thing might be a bit tripping. So we look at how things work in Node.js like that. So probably, I'm just stating the problem statement that Node.js, JavaScript has problems with code encapsulation. All the code lies all around the place. So Node.js came up with a system called as a common JS module system, which uses two properties. One is called as an export, one is called as a require. Using these properties, we encapsulate the code. This is one of the design patterns of Node.js, how it implements things. So to give you a quick example, if I have a function called as add, like this, and then another function called as add, which has 3 arguments. like this. As we already know that this whole operation in this process, this add will get overridden by this add. Or to keep this in a more sophisticated way, I'm going to create a new file called as add.js, and then I'm going to include the definition of these two inside it. Now the problem is that if I'm going to include this add.js inside the index.js file, I would get the overridden definition of this add.js. So what Node.js does is it implements a common JS module pattern to keep everything in its own namespace. To elaborate that clearly, what I'm going to do is I'm going to create one file called as add1.js and another file called as add2.js. In add1.js, I'm going to have a function of add with two parameters. In add2.js, I'm going to have an add function with three parameters. Now, in both the add1.js and add2.js, I'm going to write a statement called as module.exports equal to add. So I'm exporting this add function. Similarly, here also. Now, the way you require or include these two JavaScript files into the main file is using a syntax like this, where add1 equal to require dot slash add1.js. Similarly, add2 is equals to require add2.js. Using this design pattern, it clearly shows that you cannot directly use the add method, and this definition will never get overridden by this definition at any point. They exist in individual files and they are not loaded in memory at the same time. If they are loaded in the memory in the same time, they are using a different definition. Now, to execute the add function, I need to use something called as an add1. This way, we can check that. Now, if I use the definition of add2, you can see that it becomes not a number, because the z value is not defined. Undefined plus anything is nan in JavaScript. In a simple way, we just saw that how JavaScript takes care of injecting different functions into one file for us with different namespaces. This very feature is not available in the browser itself. So what happens in the browser? Both the JS files get loaded into the global namespace. The latter definition overrides the prior definition, and then when you execute this, you always get nan irrespective of what format you are using to load it. Does this make sense? Okay, Kapil had a question which says this: is this functionality specific to Node but not V8? V8 is a JavaScript engine that runs this whole code. This functionality is specific to Node rather than V8. So this is a way of organizing your code which will be sent to the compiler so that variables do not get overridden. Shouldn't this be add1.add? Shouldn't this function be add1.add? The point is that it depends on how you exported it. We have directly exported the definition of the method. So here, if I would have written module.exports.add, then it would have become add1.add. And here, similarly, module.exports.add equal to add, it becomes that. So now add1.add method would give us the results. This is how Node.js takes care of managing modules for you. According to Node.js, this is one module, this is another module. They both run in their own different namespace and they are loaded only once into the memory based on this definition. In Node.js, any module which you use is always loaded up into the memory or to a namespace variable using the require statement. Require, and then you use the syntax called as dot slash. Any references to modules that are relative to the current file and are not downloaded from the NPM repository, which we're going to do a bit later, is using a dot slash syntax. If it is in the current folder, it is dot slash. If it is in the parent folder, it is dot slash, and so on. The same concept of relative path gets applied here. When it comes to any Node modules that we are downloading from the server, that uses a direct way of dealing with it. So this is how Node.js loads things into its memory. So coming back to the slides, we are using something called as Node modules inside Node.js to do these things. There are three types of modules. Node.js built-in modules, which we are going to talk about in the Node.js source code. Modules that you have written, for example, the add functions, the add1.js and add2.js, and third-party modules which are coming from NPM. Besides certain built-in modules, all modules can be used in your JS file by just saying where object equal to require and module name. Whereas the files which are built-in can be called like this, whereas the ones which are written by yourself will be using the relative path. Certain built-in modules are already available to use and that do not be required. We're going to talk about that a bit later. If you go to the nodejs.org site and click on the doc links on top, this is the documentation reference for Node.js methods and all its APIs. You can see a list of API methods supported by Node.js here. For instance, we're going to talk about the OS. OS module consists of the operating system. There is a simple convention which comes with Node.js called as the API level, as with any programming language. So there is an API level associated with every single thing, which indicates if the API is frozen or if it is still under consideration of development purposes. Coming back to what we are talking, here the OS object consists of things which are available on the operating system, like os.type returns the operating system name, os.platform returns the operating system, the architecture, the release, the uptime. So quick segue from what we are talking. Venkatesh asked a question about using modules in a client-side application, that the same way how we have done it in Node.js. The thing is, the same approach cannot be directly available while working with client-side JavaScript applications. You need to use a library like a Browserify to actually achieve something like this, or you can use a require.js module to do this. You cannot directly use this kind of a syntax on your client side because this syntax is supported by Node.js to run JavaScript applications inside your V8 engine. So you cannot do this on the client side directly. Coming back to the Node.js modules we are working on right now, we're going to take up a simple module which is already available in memory, like the OS module, and then implement it. I'm going to create another folder called as example2. Inside example2, I'll create a file called as index.js. Now, the way I require a predefined module available in Node is by using like this, using just the syntax, require OS. Now, when I say console.log, let me put the os.type here. I can copy os.type and then run this. If I go back to my terminal, I'll right click on the file and say open terminal here and then run node index.js and hit return. It says I'm using the Darwin OS, which is the Apple version of it. os.platform is another property. I can use console.log os.platform, and then I can run it again using node index.js. It also gives me the same thing. As you can see from here, returns the operating system name, returns the operating system platform. If I want the architecture, that is os.arch, I can type console.log os.arch. See, I'm running a 64-bit operating system. The point here is that we are trying to use a Node module which is already available when you install Node.js, a module which is already available when you install Node.js, for example, the OS. Similarly, you can bookmark this link or docs and then go through the API references here. Each of the methods that we are going to work with, which is already available with Node.js, can be found here. So the REPL we have already looked into, the OS, the path. The HTTP, HTTPS modules are something which you're going to look a bit later on. There are other things which you can do with your Node.js application that you can typically do with any other application. We have already started using the console, and as you can see, console has many variations. Console.log, console.info, console.error, console.warn, console.dir, time, time end, trace, and assert. So you can read more about each of these things, what they do, and so on here. The process of using them is pretty simple. So like how we have been using them so far. A quick example which you can see of console.time gives us the processing time taken between two statements. Console.log, I'm going to create a label called as details. So as you can see, the it is console.time. I'm going to create a method called as console.time which marks a time. And then I'm going to write another method called as console.timeEnd and provide the same label which I've provided in time. It finishes the timer, records the output. So for example, if I start the time before an operation and then after it, you can get the list, the amount of time taken to execute that. So I can do something like this, console.timeEnd, and then I can provide the label called as details, which is giving me the details about my operating system. And then now when I run Node.js, it says it took 2 milliseconds for this operation to run. To quickly see another more valued number, I'm going to copy the exact code what is here, where an empty loop runs with a semicolon, and then you can see how much time it takes to process this. Still takes 2 milliseconds. This is another way how you can use console.time and console.trace. You can go through the documentation, which is pretty straightforward to do, pretty straightforward, and you can do it as you see here. You can always go back to the index page and look for other documentation. Okay, moving on. The next important thing which you need to know about the Node.js world is that all the modules in Node.js have something called as a Semver. Semver is a versioning system which talks about how all the Node modules are versioned. So the concept is that it has a major version, a minor version, and a patch associated with every single release. So as of now, you can see Node itself is of the version 0.12.2. That means the Node has not yet been released to 1.0 version yet. We are still working with 0.12.2 version. And coming back to the main index side, you can see all modules are also marked by the stability index. As I mentioned earlier, the stability index of 0 means it's deprecated, stability of index of 1 means it's experimental, 2 is unstable, 3 is stable, 4 is API is frozen, and 5 is API is locked. So you can, when you go through any module and you find a stability of 0, 1, or 2, you need to think twice before using it. If it is 3 or 4, take a look at what is the possibility of it being changed. When it is 5, you can use it directly, just to keep that at the back of your head. Now we're going to look at something called as NPM. NPM stands for Node Package Manager. npmjs.com is a site where you can find all Node packages. This is one of the biggest package manager out there to do package management. You can see here the way of installing Node packages is pretty simple. All you need to do is run an npm command, which will take a look at it pretty quickly. You can bookmark this site called as npmjs.com. We're going to look at a package, color, no, not color, it's for printing colors in your console. Just a second, npm module to print colors. It's called as, oh god. Okay, for now probably I'll take up another module for working with it. So let's say we're going to use chalk, I'm sorry, it's called as chalk. the module I was looking for is called as chalk. So this is for basically writing messages in your terminal in a more colorful fashion. Since Node.js is heavily inspired by colors, so heavily command line driven, so we would like to present information in a more interactive fashion like this. So for the next example, we're going to install a module called as chalk, which is basically consisting of all the colors that you need to write messages in your console. So for Windows users, there are some colors which do not work that you can check it out. I am not sure how many of them work perfectly in a Windows machine. If you use Git Bash, all the colors will work, whereas when it comes to your terminal command prompt, it might not work. So this is mostly, this module heavily works with Windows machines, and Linux operating system, this should also be working pretty fine. So coming back to our examples folder, I'm going to create another folder for session 1 called as example 3. In the example 3 folder, we are going to create or add node modules which are from the NPM repository to our application. The first thing which I'm going to do is that I'm going to open a terminal here inside the example 3 folder. So for the people who are coming from Java background, you must have used tools like Maven, which takes care of your dependency management for your application. So the same way in a Node.js, the way you start a Node application is by using a file called as a package.json. So we are going to start this new file. We're going to start a new project in Node.js using the syntax npm init. When you run this command, npm is the command which gets installed when you install Node.js. So when you run npm init, it actually asks you a set of questions about setting up the package.json file. So I will just show you how to scaffold the package.json file using npm init, and then I'm going to walk you through the features of it. First thing when you run npm init is that it asks you what is the name of your project. The name of our project is example 3. Then it asks what is the version of your project. As we discussed earlier, Node uses SymVert format of versioning your packages. So 0. The first is the major, second is the minor, third is the patch. Since we are still working with a basic application, I'm going to call it 0.1.0. The description of the application, I'm going to call this as a npm module example. What is the entry point of the application? Node.js or npm provides something called as scripts, which we're going to deal a bit later or probably tomorrow when we are talking about the package.json in detail. In the script section, what we do is that we try to invoke the starting point of the application. So here, as you can see in previous examples, in example 1 folder and example 2 folder, all my starting files are named as index.js. This is more of a convention, the same way how we do in web development, as in like index.html or index.jsp. Now I'm going to leave my entry point as index.js. If you do not want to make any change to the selection, you can directly hit enter. So you can also provide a test command. As I mentioned earlier, Node.js runs scripts which you can use to run things. So for now I'm not going to enter any test commands, so I'm going to hit the return key. You can provide a GitHub repository where your project is stored. Since we don't have any GitHub repository, I'm going to hit the return key. You can associate a bunch of keywords which you can use to tag this application. So if you're pushing this particular repository to the npm package manager's repository, that is npmjs.com, you can provide a list of tags keywords which you can mention so that people can search your application easily, like this. We are not going to provide any keywords, or you can provide a keyword like example and then say node module. Who is the author of the application? So I'm going to provide my name. What is the type of the license of this application? I'm going to provide an MIT license. And then it asks you the question, this is the package.json I'm going to generate. Are you okay with it? So it says name example 3, version 0.1.0. The description is npm module example. Main is index.js. We have a script called as test, which says not specified, and it exists. and then we have a keyword called as example, node, and module, the author, and license. If you're okay with it, you can hit the return key. If you don't want it, you can hit no. I'm going to hit the return key, and it says the file is generated. If you go back to your project folder, the example 3, you should see a file called as package.json created. This is a JSON file which consists of all the information which we had right now. Now, if you want to install any external modules of a Node application, you can go to npmjs.com and search for that particular package or a module, and then you can get it. So for instance, you can go to npmjs.com, and this time I know the name of the package, which is called as chalk. I hit the return key. You get a list of matching packages for this particular query. Click on chalk, and then you get the version. Here, generally you will have a command on how to install it. It says npm install -- save chalk. Let's take a step back on understanding the npm command line tools. One command which we have already seen is called as npm init. As you already know, this npm command is used for initializing a new Node project with package.json. The next command is to install a new Node package. You can run npm install chalk. So this is how you install a new Node package. When you run npm install chalk and hit the return key, it is going to go download and then fetch the npm module called as chalk. If you go back to the example 3 folder, you see that a new folder named Node_Modules is created, and inside that the chalk folder is downloaded. So this particular file consists of the functionality of chalk. If you open the package.json, nothing much has changed here after we install the package. So the idea of package.json is that this is like the project definition file. Since anybody in your team is going to use the same project file which you are using, you do not send across the common Node modules which you are using across your application to your teammate with every code check-in. It is a waste of space. Instead, what we do is that we mention those information inside the package.json file, mentioning that, okay, this is my project called as example 3, and these are all the dependencies for my project. So the way you add a dependency, like for example, we are using chalk in our application. The way you mention the dependency in your package.json is by adding another property called as dependencies, and then you mention the dependency here. Another easy way to do the same is when you install chalk, you can add a flag called as --save. When you run --save and hit return, the package gets downloaded. At the same time, it gets added to your package.json under a section called as dependencies automatically. So from now on, whenever you're checking your file into your Git or your Subversion, you can ignore the Node_Modules folder and ship the Node.js file, this package.json file. And when your teammate receives this package.json file, all he needs to do is run npm install. So let me go ahead and delete the Node_Modules folder, and let us assume that I am the teammate who has received the project file, which is basically package.json as of now, and then I know that I need this particular dependency to be installed on my machine. I go to the terminal, I'm pressing Ctrl L on my machine to clear the window, and then I run npm install without any name of the package. When the npm install command runs without the name of the package, it searches for a package.json file in the current folder and installs all the dependencies. So let us say npm install, and I hit the return key. Now what happens? It downloads the package.json. It downloads the dependencies from the package.json file. So this is one easy way to manage dependencies across projects, where you need not ship the code with ship the dependency code with the source code. So moving on, what we are going to do is we're going to install another way of doing things. So there are two sections in a package.json called as dependencies and dev dependencies. There are so many modules out there in Node.js which has which you're going to use for developing your core application, and some modules which you're going to use for managing those applications. For example, a build tool, like you use Ant in your Java application for building. Similarly, in Node.js, we have a tooling system using Grunt or Gull to manage the project for you. There are two types of dependencies, as I was talking about. One is called as dependencies and one is called as development dependencies. A module like Chalk, where you would like to print messages in your application in a colorful format, is part of your application's code. For example, you would like to use another module for processing or minifying your file. That is a module which will be used for developing dependencies. That will not be shipped with the product, but that will be used for managing your product. So let us assume that we're going to use a module called as, let me Google it, let me search in the packages, called as minify. As you can see, there are so many modules out there which run the minification process of minifying CSS, JS, HTML and images. So I'm going to use this package called as minify. We are not going to implement the package in our application, but this is to show that there are two types of packages that you will be needing when working with your application. One that are used as part of your core application logic, and one that will take care of managing your application for you. Minifying is a build script that will take care of managing the application for you. So this will convert a particular file into a minified file. We are not going to implement, as I mentioned earlier. The only thing we are going to do is that we are going to add this as a dependency to our project. So when you add this particular module, which is called as minify, the way you do that is that you say npm install minify --save -dev. The only difference between the first way of installation and the second way of installation is that you add another postfix to your --save called as dev, which tells npm or the package manager to take this as a development dependency and not to push this in case you're running a production environment. We'll talk more about managing production environments a bit later on. If I go back to my package.json, you see that this particular minify is available as a dev dependency, whereas the chalk is added as a dependency. But both of them are downloaded inside the main folder, as you can see here. This is how you generally install a package which is available in NPM. If you would like to uninstall, all you need to do is npm uninstall and the package name. If you run npm uninstall and the package name and hit the return key, it will be removed from the Node Modules folder, but it will not be removed from your package.json. If you want it to be removed from your package.json as well, add the --save -dev flag, which will take care of uninstalling and removing it from your dev dependencies or the dependencies as well. The same thing goes for the normal dependencies as well. npm install chalk --save, and then this would uninstall the Node module as well as remove it from the dependencies. These modules, whatever you see when you run npm install chalk, this module get installed locally, as in like this. Now I'm going to create a file inside my example3 called as index.js file, and then I'm going to require the chalk package, where chalk equal to require chalk. Right? Now, I would like to print a few statements in different colors. So I would like to go back to the documentation and refer. You can go back to npm, search for the package, click on the package, and then you generally have the documentation available with it. You can also read other information about these packages, as in like highly performant, doesn't extend string.prototype, expressive API, ability to nest styles, and so on. It is used by more than 3,000 modules to print colorful values. So you can see on the right hand side what this module depends on. It depends on support-color, has ANSI, escape string regex, and strip ANSI and ANSI styles, are used for building this project, whereas this module is used in all these packages. The way you can use it is as you can see from here. Var chalk equal to require chalk. You can style a string like chalk.blue equal to hello world. So this is as good as writing console.log hello world but print it in blue color. Now going back to the terminal, I'm going to clear the terminal and then run node index.js. I need to wrap this in console.log. As you can see, this prints in blue color. So this typically converts your string into a color that is understood by your terminal. So for example, you can pass in multiple arguments to this, or you can also have a foreground color and a background color. So I'm going to take this and do another console log. Now you can see it's print in blue color with a background as red. So this module, what you're looking at, and this API is specific to this module. The only thing which you are going to take away from this example is how to use a module which is available in NPM, how to download it, and how to set it up inside our project, and how to consume it. Most of the times the README files are very well documented for us to keep using it. I'm going to do another example which talks about theming files for this module. So you say var error equal to chalk.bold.red. So it is creating another variable called as error which takes in the value of chalk.bold.red. So now when I say console.log and then I can write error, then now I go and run this, you can see this is now in red color. So this is as good as replacing like this. The output is still going to remain the same, but you're going to see some colors flowing in with the chalk library. So typically this is how you do this. You can also have other API methods which is available in this library to use it. So to identify a list of styles that is supported, you can find here. Anything issues, so here, if you are on Windows, do yourself a favor, use cmdr instead of cmp.exe. So if you want to print colors, guild bash works most of the time for all the colors. There's an issue with 256-bit colors. Chalk does not support anything other than base 8 colors. So you can read more about the documentation of each module which is available here. You can also, on the right hand side, see the link to its location on GitHub. When you click on the link on the GitHub, it takes you to the GitHub page where you can see how this module is coded. I'm a curious guy. If something like this is implemented, I would like to go about checking where it is written, how it is written, what does it do. If you are evaluating a module and you want to see how popular it is, you can check out the stars, the forks. You can click on the issues and then you can see how many issues are there which is open and then how many are closed. You can use the GitHub's search filter to see whether if it works or not. So let us say that you are a Windows guy and looking at Windows issues with Windows. I'll say is:issue and then Windows, hit enter. So it says chalk.green, chalk.gray dim not available. So here you can see what happens. You can go through the issues, talk to the guy who was written, and then so on. This is one way of looking at applications or following the applications on GitHub and see where it works. So this is one way of installing Node modules on the machine, as you can see here. The basic thing is that we spoke about the 5 modules which Chalk is dependent on. And you can see from here, the Chalk module, which is present inside the Node modules, has another Node modules folder which consists of the 5 dependencies. And when you open any of the dependencies, if they further have any dependencies, those will also be listed or downloaded when you do this till you reach to a package which does not have any further dependencies to be loaded. This causes a big concern for people running Windows. There are some modules which are so deeply nested that this go beyond 60 or 70 folders deep, And when you're trying to delete the Node modules folder, it does not happen that easily because Windows can delete only up to 40 folders. So typically, these architecture of packages is something close to Linux than of Windows. NPM stands for Node Package Manager. It is actually not an acronym. NPM is not a Node.js specific tool anymore. NPM is basically a registry of reusable modules and packages written by various developers. You can publish your own modules, as I just mentioned. There are two ways to install NPM packages. One locally that we use and depend on the package from your own module or project. Two globally to be used across the system. It's more like a command line tool. We're going to work with it later. Installing a package locally is as simple as running npm install and the package name. This will create a Node modules directory and will download the package there. And then once it is installed, you can use require syntax to actually get it. Another way of saving packages locally, as we have seen, is using the package.json file. Once you have a package.json file in your directory, you can run npm install. All the package names listed in there will be downloaded. So the same thing which I told you. The local here, what I mean is on your machine, on the server where it is running. On the machine where Node.js is running, that is referred to as local. The npm install --save will add the package to package.json as we have seen. So you can also manually enter the package.name using the dependencies object literal notation that we have seen earlier. When you create a package.json, only two things are important. One, the name, and the second is a version. The npm init process generates other properties also. And you can also add your own set of properties to package.json to give more definition and meaning to that file if you require. So there is a way you can install console. There are two options here, but I prefer using the git bash for doing things more efficiently. So the process of installing a global module is running npm install -g and the package name. In case you're running, in case you're installing it in a folder or a global folder where you do not have permissions on a Linux, Unix, or a Mac system, you need to use the sudo command. And Windows user needs to run this as run as and launch their command prompt and then use it. We'll just go back a couple of steps about objects in JavaScript. So we spoke about the introduction of JavaScript. I'm going to run through the following slides and then talk about objects in JavaScript. So what is an object in JavaScript? Object is a group or a collection of properties or attributes. Properties or attributes is a name-value pair, as we have seen earlier. In some cases, value is a function or a property. So in JavaScript, a property can be a function, a variable, a number, another property, and so on. Generally, the way you access a property is using the dot notation or the square brace notation. To get all the properties in an object, you can use the for-in method. As I mentioned earlier, if you want to try any of these things, you can open up any tab in your Firefox or Google Developer Tools and then start doing things with it. So the way an object looks is where O equal to double curly brace object. So O is now an object. The way you add a property to it, O.name equal to my name. Then I say O, you can see name is one of the property, and using the O.name syntax, I can get the value. Another way of getting a value from the object is using syntax. Object.name is name. This is the simplest way of analyzing what we just read. If you would like to know how many properties are there in an object, JavaScript provides a method on the object called as keys. Object.keys of O, and you hit return, it tells you how many keys are there on the object. If I add another key and say O.age equal to 100, now when I run object.keys, you see that there are two properties, which is returned in an array format, and you can iterate over this using the for-in syntax, or you can also use the for each syntax. So if you're using the for loop for var I equal to 0, I less than object.keys of O.length I plus plus. Console.log, I can do O of object.keys of I. Probably I should have cast this variable of I, something like this. And now if I take this, let me probably have some indentation so that you guys can get a feel of. I'll probably do it in my Sublime text and then share it with you guys. So I can say something like this, where props equal to object.keys of 0, props.length, O of props, O of props of I of this. So if I take this, clear everything, paste it, you should see the values. Or to be more explicit, I can say the property colon value. Oh my god, I'm really sorry. I'll just leave the syntax on the page, as in like where props equal to object.keys of O, where I equal to 0, props.length I plus plus, console.log props of I, O of props of I. So that is name is my name, age is 100. So Kapil, I guess this answers your question. So this is how we generally use the object notation to iterate the values. Yes, this is the native object in JavaScript. Moving ahead, you can also use the literal notation to define the objects, as in material, height, tree, color, and then you can also assign functions to properties. Notice that it is a colon and not an equal to while creating properties in an object. Using the constructor function to define objects. As we saw earlier in the MDN link, you can use the same definition. So function treehouse equal to name, tree, and color. By convention, start constructor function names with a capital letter. This dot house equal to name, this dot tree equal to name, this dot tree name equal to tree, this dot house color equal to color. You use the new keyword to create as many treehouse objects as you want. Every functions get a property by default called as prototype. When using a constructor method to create new objects, you can assign properties or methods to the prototype of the constructor function. For example, this is shared by all objects created using that constructor. Function, treehouse, name, tree, and color as shown earlier. Treehouse.property prototype.owner is Mike, where John's treehouse equal to new treehouse of John, Oak, and Ellen. But when you do a console.log of John's treehouse.owner, it will print Mike. To show this more visually, what I'm going to do is that I'm going to take the function here, I'm going to type it up in the Sublime text editor, and then paste it in the console and show it to you. So function treehouse, name, tree, and color. Say this dot house name equal to name, this dot tree name equal to tree, this dot house color equals to color. Just cross-checking it, this dot house, this dot tree name, and this dot house color. When I copy this, sorry, this is a constructor function, so capital T. Copy this and I paste it inside my terminal here. Now, the beauty of Chrome DevTools is that when you type the name of the function, it gives you the definition. There is a method in developer tools of Chrome called as div, dir. When you say dir and provide the name of the function, it evaluates it for you and gives you the object equivalent of treehouse. If you open this, as we spoke earlier, there is another method called as prototype. This consists of all the properties, which is constructor function, which we have used just now, and the definition. It also talks about the scope in which this function exists. Since I executed this function directly in the console, it is inside the global object or the window. We're going to look at the scope of the function a bit later on. It consists of 3 arguments. So when you say dot length, treehouse.length, it gives me the number of arguments it has. So this is one way of identifying number of arguments a JavaScript function has. Coming back to our problem at hand, we're going to say treehouse.prototype.owner. So when I type in treehouse, when I start typing, you see the prototype property. As of now, there are no prototype properties on this particular function. Dot owner. I'm going to say Mike. Right? Now, when I dir treehouse, you can see that there's a prototype property called as owner attached to the method definition. Now, when we use this method definition to create a new instance, as we have seen here, John's treehouse, John, Oak, and Elo, and then I say John's treehouse dot owner, you can see Mike. So this property is available at a function level. So you say house color is yellow. Now, if I say where Jane's treehouse equal to new treehouse of Jane, Oak, probably green. Now, when I say Jane's treehouse.owner, this property is shared between both John's treehouse as well as Jane's treehouse. Whereas the other properties like Jane's treehouse.house color will be different from Jane. So as you can see from the command line, it is pretty straightforward for you to evaluate these examples as we keep along so that you can know more about it. So this is how, when using a constructor method to create new object, you can assign properties or methods to the prototype of the constructor function. This particular methods which you add on the function definition using the prototype syntax is shared across is shared across all the instances of the object. Whereas when you use it inside the property, it is specific to that particular function. This is why the JavaScript is so amazing. So the freedom of usage, because it has a simple syntax called as object.create. Here, if you see where treehouse equal to name, a color, and you have a method called as do something. Here you can directly create a new object called as John's treehouse by creating a property called as object.create treehouse. That is this. Now you say John's treehouse.owner is made. Same thing, you guys can copy this example into your notepad and paste it into your terminal, and using the dir syntax you can evaluate it. Because JavaScript has dynamic object extension, you can add anything to your John's treehouse object at any point of time. If the property you're adding already exists, gets overridden. If you do not, it does not. One simple example of this particular feature is that I'm going to clear my console. There is the string of say 0, 3. It's going to give me 3 characters using the substring method on the string type. Right? Now, the beauty of JavaScript is that I can say string dot prototype dot my own method. And then I can write a function here which can do process with it. I'll say console.log hello world. Sorry. Hello world from my own method. Now, when I say hello world, which is basically of the type string, I have this method called as my own method. And then it prints the value. This is what makes JavaScript very awesome to use. This is how we create dynamic object execution. One simple real-time use case of this is that in Internet Explorer 8, the method called as trim. So for example, hello world, as a trailing space, I use the trim method. It trims the last space. This trim method is not available in Internet Explorer 8. So what we do is, there is a concept called as polyfills. We write a method called as string.prototype.trim, and then here we write the regex, like regex of something like this dot some value dot replace /s g comma empty string, something like this. I'm not sure about the syntax, but now this trim method will be available on hello world. This is how most of the JavaScript polyfills work. It takes in the features which are not available and you bind it to the prototype of the particular method or the class, and then it starts working. This is how dynamic objects work in JavaScript, which makes it super awesome, as you can see here. You can also clone variables from one property to another property. For example, you're using a library like _.js, you can use the _.extend method to copy all the properties from the source object to a destination object. You need to understand that in JavaScript, all the objects are passed by reference. So if, as you already know, since it's passed by reference, any property you update in the child methods will ensure that the value available globally will also get updated. So there are two types of copy, as you know, shallow copy and deep copy. In JavaScript, they typically do not make sense much. So it's all passed by reference. If you want to make sure that you do not want to extend any of the properties from one place to another, you can use the JSON API to stringify and then move from one object to another. What I mean is this. I'm going to clear this, where a equal to an object. So where b equal to a, b dot prop equal to value. Now if I see a, it gets cascaded to that since it's passed by reference. If you need a scenario where you do not want to copy the reference of this, the way you do that is that you say where b equal to JSON dot stringify of a. And then b will now just consist of the definition of it. Then you can say b equal to JSON.parse of b. Now there is no relation between a and b. There is no relation between a and b. So now if I say b dot new prop equal to prop, a will not be updated. This is how you delink values in JavaScript. The use of _JS is that it avoids doing all this by yourself. This is a bunch of utility methods available in JavaScript which you can easily use in _JS as a library to extend objects, values, and so on. So if you want to take two objects and merge them together, you have this _extend method. You have this is object 1 and this is object 2. When you run this extend method, it creates a new empty object, takes in this, merges with that. So these are generally used as utility methods. _JS provides a lot of such utility methods to do things. So array processing, iterating, common examples or common properties that you would be doing in JavaScript is achieved using _JS. It is one of the libraries out there. So in JavaScript, there is no need of constructors. We can use it as factories. So like this, treehouse equal to function owner, where object equal to object.create of treehouse, object.owner equal to owner. Remember, we had set a same factory owner to every single person, like this. When you instantiate a treehouse factory, which internally calls this method, passing in this value so that this whole object gets created at runtime. So this is the simple factory pattern which we can use to generate objects of treehouse. Another more important concept of JavaScript is called as closures. Closures help you to write good code. This is one of the ways of handling event loops. When a particular function goes into an event loop, it needs to carry all the information it has in that particular scope, so that when the callback is completed or the IO operation is completed, it will execute the function inside the callback. So we have not written any program so far which implements a callback, but we're going to do that later on. But to give you an idea how it happens in the background, closure is your answer. A closure is created when a function accesses a variable outside its immediate scope. In JavaScript, a function can return another function, which is pretty strange for a programming language. So when a function returns another function and the returning function uses properties of the parent function, then it is called as a closure. To quickly illustrate that, let's say I have a function add x. Then I say return function y. I say return x plus y. This particular function add returns another function. So to illustrate that inside the browser, I'm going to clear this and type function add x, return function y. Remember, add will not work directly. I hit enter. I'm going to create a variable called as add5. And then I'm going to call a method called as add5. Now, add5, if I directly print it, consists of the definition of another function which uses the value of x being passed here. Now, I want to sum up 5 with some other number. Add 5 of 5. I should get, oops, I'm sorry. I'm really sorry. I'm going to type that again. I'm going to create an add 5 function, and then now I say add 5 of 5, I should get 10 back. Now, add 5 of 15, I get 20 back. As you can see, the way closure works is that when I'm executing the child method, it stores the properties of its parent. That is, x is accessible here even though the function has finished execution. This is typically, I don't know, I don't think so it's correct to call as a callback, but it is a method which is written by the parent function. Very important point in JavaScript is that if a function returns another function, it is not called a closure. But if a function returns another function utilizing a value which is available in the parent function, then it is called as a closure. Node.js uses a lot of closures to get things done. Going back to the slide, you can see where a equal to 2, you have another function, where b equal to 3, you have another function, c equal to 12. If anything inside the middle function is used from the parent function, the middle function automatically becomes a closure. So, function constructor treehouse, var owner equal to Mary. Function cut wood, return owner plus go and cut some wood. So here, the owner value which is used from its parent function is now called as a closure. Because of the ease of functional programming in JavaScript, similar functions can be reused, right? Simple example. Many utility libraries available for this use like Highlander.js or underscore, you can explore them. Just a quick recap of what we have done in today's session. An object is a collection of properties, attributes having a name and value. These values can be functions also, when so they are called with methods. Literal notation for objects in JavaScript include the double curly braces. The constructor notation using a constructor function with a new keyword. We also spoke about the prototype methods, how you can add more properties to an existing function. We can use the object.create method to create methods. We can clone objects using object.clone. we would rather use a factory than use a constructor, as we have seen why. We can also see how closures work.